In this video, we'll take a brief look at the particular building processes involved in the construction of passive houses. Building company Valhalla Living specialises in designing and constructing energy-efficient homes, and in particular passive houses. We'll be looking at two projects which are very different in design and have achieved different levels of energy efficiency. This one reaches complete passive house status, while this one doesn't quite meet the very strict requirements to do so. So what exactly is a passive house? Kim Feldborg, designer and builder of his own passive house near Taupo, explains.
A passive house is a building for which thermal comfort can be achieved solely by heating or cooling the volume of fresh air required to provide a good indoor air quality. If we take a look at the details, the heating or cooling load must be less than 10 watt per square meter. Alternatively, the annual space heat or cooling demand must be less than 15 kilowatt hour per square meter per year. The air tightness required must be less than 0.6 of an air change per hour with a pressure difference of 50 Pascal. And finally, the primary energy demand must be less than 120 kilowatt hour per square meter per year.
To achieve these very specific criteria, there are 5 key points to be considered. The first of these is thermal bridge-free construction. Thermal bridge-free construction starts right at the very beginning of a build.
What you can see here is a concrete slab sitting on a bed of polystyrene, which minimizes the heat loss to the ground. But the polystyrene also wraps around the entire edges of the slab to minimize any heat loss to the atmosphere. This example shows a traditional concrete slab combined with an aerated concrete nib wall placed on the edge of the slab. The timber framing is then erected in a normal way, but it's sitting on top of the nib wall.
Unlike traditional timber construction methods, which incorporate 90mm framing, passive houses are built using framing that, depending on the design, is either 140mm or larger. This leads to improved insulation values being achieved as required within passive house criteria. Despite this, when you see a passive house structure from a distance, there is no perceivable difference to a conventional standard build. The second key point, insulation, is a vital component in this kind of construction. In this instance, we have used a blow-in insulation product, and here you can see the insulation material being packed tightly into the external wall frame cavities. As you might expect, roof areas are also heavily insulated. In this project, a wall insulation value of R5.5 has been achieved, and the roof insulation value is R8.2. By comparison, the wall insulation value in this house is recorded as R4.7, with the roof insulation being R7.9. Despite their differences, both these sets of values are well above those of a traditionally constructed house. The third key point, window technology, is very important in any house building project, but especially so when we consider passive houses.
Windows must perform to a very high standard. Both the houses we are looking at here were built in areas that requires triple glazing and high performance window framing with an R value of 1 or higher.
The fourth key point we must consider is airtightness. It is essential that this is addressed in the planning process because the airtightness membrane often needs to be installed in awkward but critical places. Places that are not easily accessible retrospectively at a later stage.
To achieve the airtightness required, it is important that an airtightness membrane is taped to the window frame before installation. Mounting brackets are also fixed to the window frame at this stage. Once these steps have been completed, the windows can be installed and fixed to the framing. The same membrane material is fitted to the inside of the external wall frames. It is cut away and shaped to cater for the window's aperture, and the membrane that was taped to the window frame before installation is then folded over and taped to it to form a sealed joint.
Airtightness is essential in all energy-efficient houses, and passive houses in particular must not allow any air leakage more than 0.6 of an air change per hour. So how do we confirm that we have achieved that?
To test the airtightness, we are using what is called a blower door. The blower door incorporates a fan which pressurizes and depressurizes the entire house. Associated computer software monitors this process and then confirms whether our goal has been met.
The final key point to consider is ventilation. Airtight passive houses might be warm and cosy, but to ensure that occupants can enjoy warm, clean, fresh air inside while the stale, moist air is evacuated, a ventilation system must be installed.
The system we used in these two houses is the comfort system developed by Zender. It is a heat recovering ventilation system with an efficiency rating of 94%. It means that it can transfer 94% of the heat from the stale extracted air to the fresh incoming air.
Once the ventilation ducting, the services and cabling have all been installed, further insulation material is packed into the service cavities. Finally, the walls can be jib-lined and stopped to make way for the usual fit-outs and decorative finishing, which can all take place in the traditional way. For further information about passive house technology or energy-efficient homes, contact Valhalla Living. Alternatively, you can visit their website